Hi folks, today I have a lesson for you on rates and stoichiometry. So over here we are going to relate rates and stoichiometry together. So in a chemical reaction, reactants are consumed and products are produced. Hence, the rate of disappearance of reactants is equal to the rate of appearance of products because the reactants are being consumed and the products are being produced at the same rate. So, for example, over here we have an equation 1a plus 2b forms 3c plus 4d, where a, b, c, and d represents chemicals, and the 1, 2, 3, and 4 are the coefficients of the chemical equation. Now, rate of A is equal to change in concentration of A over change in time, and the rate for B is going to be change in concentration of B over the change in time, and same way for concentration of C, the change in concentration of C over change in time will be the rate for C, and for D it would be the change in the concentration of D over change in time. Now, the rate of one substance can be related to the rate of another using stoichiometric coefficients. And this is very powerful because if you know the rate of reaction, if you don't you know the rate of change of one reactant or one product, then you can use that to find out the rate for the other reactants, consumption or production, right? For the reactants and or products. So for example, at the bottom I have change in concentration of A over change in time. What is that equal to in terms of B? Well, if I find my pen here, right here. So in terms of B, what would be the rate of change in concentration of A over change in time? Well, it is going to be half as fast as the change in concentration of B over change in time. Half the speed. The rate of change of A is going to be half as fast as the rate of change of B. Because if you look at the chemical equation, 1A uses 2 B's to form the product. So the rate of change of A is half of that of B. Also, we can relate it to C. In terms of C, it is going to be 1/3 change in concentration of C over change in time. Now, there is another difference here. A is a reactant, C is a product. In other words, one is being consumed and the other one is being produced. Hence, we'll have a negative sign. It will be opposite, right? So whatever is the rate for A, the C, because it's on the product side, it would be the opposite sign. And we can do the same thing for D. This is going to be equal to 1/4 change in concentration of D over change in time, and the negative sign representing that it is being produced, because A is being consumed, D is being produced. They are opposites. They are not on the same side of the equation. They are on the opposite sides of the equation. So note, rate is always positive. The rate cannot be negative, right? So in this case, rate of production is always positive. The sign is indicating if the substance is being produced or consumed, right? So if we are trying to relate things to A, which is being consumed, then C would be negative and D would be negative. If we had this changed, and let's say we were trying to look for concentration of C over change in time, and we were trying to relate it to A, for example, that would be 3 times change in concentration of A over change in time, and because C and A are on the opposite sides of the equation, this would be a negative. Okay, so I hope this helps to understand how to determine the rates and how to relate rates of one reactant or product to another, and helps you understand how rates are related to stoichiometry.